Okay, here we're going to look at feedback loops and how they relate to the body. So while this initial example here looks at kind of like an engineering standpoint, I kind of like the suggestion of the infinity sign because our body is constantly going back and forth trying to maintain homeostasis, and that's exactly what's kind of going on here with feedback loops. There's a way to kind of raise something, there can be a way also to lower something. But we're going to look at two specific types of feedback loops here. So starting with the first one, we call a negative feedback loop. This has a response that is reverse of the change that's detected. So an example would be thermoregulation and blood sugar regulation. Look here at body temperature. So we have our normal body temperature. If the body temperature decreases, well, what's going to cause through a negative feedback loop is the body's going to shiver, and it's going to cause an increase in the body temperature. Now, if that body temperature increases too much, well, then we're going to have the negative, which is basically the opposite effect. We're going to have cooling mechanisms, such as sweating, that occurs that help us reduce our body temperature. So looking at negative feedback, if something's decreasing, then we're going to cause, the loop is going to cause an increase to occur, and just vice versa. If an increase occurs, we're going to have a decrease. How this looks in a little bit more complicated sense is the release of adrenal glucocorticoids, which is stimulated by the release of hormones from the hypothalamus and pituitary gland. This signal is inhibited when the glucocorticoids levels become elevated by causing negative signals from the pituitary gland and hypothalamus. So we have our homeostasis, we have our nice happy body conditions. We have an imbalance that occurs here. So within the body, the hypothalamus perceives low blood concentrations. So that's causing an imbalance. What that's going to relate to is a hormone to be released. This hormone release is going to cause a cascading effect to help increase these blood levels. These blood is going to be released in the various glands, which will hopefully cause a correction to occur, and that correction will be evident by the levels increasing in the blood. These increased levels, though, when the hypothalamus perceives normal concentrations, it will stop releasing that. So here initially we had the release. The negative feedback system is now causing the stopping of release of that, resulting in homeostasis to occur. So keep in mind, negative feedback is when if something's going to stimulate something, then there'll also be a way to kind of suppress or reduce that from occurring. Now the opposite of negative feedback, as you might have guessed, would be a positive feedback loop. And this involves the response that reinforces or amplifies the change detected. Childbirth is one example, in blood clotting. We're going to look specifically here. These two examples show childbirthing. So here's the nerve impulse from the cervix to transmit to the brain of the baby's head pushing against the cervix. The brain will then stimulate the pituitary gland to release a hormone. That hormone is carried into the bloodstream to the uterus, and it stimulates the contraction of the uterus towards the cervix. That will then cause the baby's head to hit against the cervix again, causing this to kind of go around and around. See that same thing here with positive feedback. Keep in mind we're amplifying the signal. So stretch receptors are activated in the uterus as the baby's growth takes up larger space in the uterus. This will then signal the brain to release a hormone, oxytocin. This then will cause the uterine muscles to contract. Contractions will get stronger until the baby is delivered. We have this positive feedback. We have this kind of building or amplification of this signal occurring. So hopefully that gives you a little bit of a background between negative feedback loops and positive feedback loops.